Hi class. This is going to be a talk about scientific notation. Uh, you probably already know everything there is to know about scientific notation. Of course, this is going to be in conjunction with the correct number of significant figures. But best way to learn is by example. And so we were going to take these same numbers that we did before for significant figures and do exactly what the question asks, is express it in scientific notation with the correct number of significant figures. So in this case, you remember what scientific notation is. Scientific notation is you express this in terms of a number between 1 and 10. So in this case, it's going to be 7 point something. And then it's going to be times a factor of 10 to shift the decimal place. Now what you do, you count the number of the numbers that are below it up to the point. So you count 1 and 2 in this case in order to get 10 to the 2. So this would be 7.110 times 10 to the 2. Now I'm going to have to highlight that and click that and make it a superscript. And there we have the number properly expressed as scientific notation. It's got 4 significant figures, the 7, 1, 1, and 0. It's a trailing 0, raised to the second power. Times 10 raised to the second power. Now, when you have numbers that are less than 1, the way you count are the zeros starting in the ones place to the first non-zero number, not including that non-zero number. So in this case, we only have 1 0, the 0 in the ones place, and that means we're going to have 10 to the minus 1. So this is going to be 2.39 times 10 to the minus 1. And we make that an exponent. Not the whole thing. There we go. All right. So this one is in the thousands. They didn't write it with a comma, but we can write it with a comma. And express this in scientific notation. It's going to be 9 point something. So, well, you know what's funny? Here in the United States, we use a comma in the thousands place, to separate the thousands place from everything else. And we use a point, decimal point, to separate the ones from the less than ones, the fractions. And in Europe, it's exactly opposite. They use a point to represent thousands and a comma to represent the decimal point. So you may encounter that. Just beware. 9.0743. It has 1, 2, 3, 4, 5 significant figures times 10 to the, you start in the ones place, 1, 2, 3, 4, 10 to the 4th, and we make it an exponent. Okay, this one's got 4 significant figures, 1, 2, 3, 4, and 1, 3, 4, and 2. And so again, we make it a number between 1 and 10. So it's going to be 1.342 times 10 to the, now you count up from the ones place, all the way up to just below the first number. So it's 1 and 2. So it's 10 squared. And make it an exponent. There we go. Boom. All right. This one, again, you make it a number between 1 and 10, so it's going to be 5.499. Remember, leading zeros do not count towards significant figures, so it's only 4 significant figures, times 10 raised to the, and now you count from starting from the ones place, that's 1. It's actually negative 1. And this one is negative 2. So it's 10 to the minus 2. Now, this is the one that did not really obey the rules as they were laid out, or you had to have experience with the rules to understand that if this was not considered, if this was considered a significant figure, then these zeros were captive and not necessarily trailing to the left of the decimal place, which I consider to be a wildly complicated understanding. If it's got a point in it, they all count, and that's exactly what it is. So anyway, it's 1 followed by 5 zeros. So it's 6 significant figures. 1, 2, 3, 4, 5 times. Now you count the zeros starting in the ones place. 1, 2, 3, 4. 10 to the 4. And you make it an exponent. And this one is 7.38592 times 10. So you count this 0 in the ones place, that's negative 1, 2, 3, 4, 5, 6, 7. 10 to the minus 7. Okay. Let's do as the question asks, what's the number of significant figures? Well, these are written with the correct number of significant figures, but I'll just write the significant figures here, which is going to be 4, 3, 5, 4, 4, 1, 2, 3, 4, 5, 6. 6 significant figures. Okay. Oh, we didn't do this one. This has got 1, 2, 3, 4, 5, 6 significant figures also. Counting the significant figures in scientific notation is a lot easier than in free form. So, because it's just the complete number of digits you're given. If If there are trailing digits, they were meant to be there, and there are no, trailing zeros, and there are no leading zeros. There's always a point in the number, and so the trailing zeros always count. Okay. Also, scientific notation numbers are never integers. They're never counting numbers. Okay. Every one of these could be expressed with the letter E. That's another notation that's frequently used in scientific notation. It's usually frequently used in computer programs or programming languages, and it's also used on the calculator. So this would be 7.110 capital E O2. Now sometimes a second, sometimes it's a two field. Sometimes the field is two. Sometimes in computer languages that you put a plus or minus right there. So let's do that. Sometimes the field is only 2 digits long, or it can be as long as you need it to be. Now let's do it that way. So this is 2.39 capital E minus 1. This is 9.0743 capital E plus 4. This is 1.342 capital E plus 2. This is 5.499 E minus 2. The E means times 10 to the. Let's get these things away from these dashes that look like negative signs. I don't mean them to be negative. Uh, 1.00000 capital E 4 plus 4. Okay, now that's the way it would be written in computer code. Oh, we got one more. 7.38592 E minus 7. That's the way you'd find it in computer code. On your calculator, the way the pluses and minuses are entered, the plus is usually assumed and the minus has to be entered with a plus minus key. So let's enter some of these things, and I'm going to oh, what just happened? Okay. Turns out I cannot show it to you. Let's pause until I get this thing figured out. Okay, class, let us continue. I have installed some software that lets us see things. Let's pull this up. What I'm going to do is enter these numbers. Let's take the first one, 7.11e plus 2. And you see how it's entered on a calculator. Okay? This is the star. 7.112. And you see this button down here that says EXP. This is your times 10 to the button. You push that. And normally you just put 2. The default is plus. And then you hit equals. And it will put it back into normal notation, 711.2. If it's not too big otherwise to be displayed. If, however, let's go to one that is negative. Oh, it was 7.110, not 7.00112. Anyway, let's go to one that's negative. 2.39 e minus 1. Okay, so let's go here. Clear. No, all clear. Dip, dip, dip. 2.39 1, and then you can't hit the negative. That's for the operation. You can't hit the negative. That's for the operation of minus. What you have to look for is the plus minus key, which is, in this case, it's over here. Up, up, up. In this case, the plus minus key is right here. And so you hit that while you're in the exponent, and you see the negative appears up there. Now, you're going to retrieve the number that we wanted when we hit the equal sign. Okay, it puts it back into normal notation. If it was not too big to otherwise fit on the screen. So that's the way these numbers are entered as scientific notation on a calculator. You have to use the plus minus key once you're in the exponent in order to get the negative. The default is already plus. That's all I wanted to say about that. Thank you very much.